Here's a quick review for Chapter 8. Try to create a Venn diagram for these three pairs of items: a folded mountain and a volcano. Remember, Venn diagram over here on the left side would be all the stuff about folded mountains. On the right would be all the stuff specifically about volcanoes. And down in the middle here would be all the things that they have in common. So think about that. And then you think about lava and a pyroclastic flow. What do they all have in common? What are their differences? And then a volcano and a geyser. Um, Talk about what they have in common right here in the middle, and maybe think about some things that make them different on the outside. In areas where the lithosphere is being pulled apart, the crust does what? What it does is it makes more boxes, I guess. What it does is it breaks them into blocks separated by faults. When two plates are carrying continental crust, when they collide, what happens there is that the rock will fold. Now you should be pausing this between all of these. The movements of huge blocks of rocks along a fault can produce, think about which ones are lava plugs, volcanoes, fault block mountains, or folded mountains. I think along a fault would give you a clue, and that clue would say that it's a fault block mountain. Volcanoes in the Ring of Fire are supplied with magma rising up from, well, that whole Ring of Fire. Is it the spreading center? Are they hot spots? Are they rift valleys or subduction zones? The Ring of Fire is full of subduction zones. Before magma erupts, it collects underneath the volcano in the crater, in the vent, in the caldera, or the chamber. And the chamber is the part where it gets collected up. The most explosiveness of a volcanic eruption depends mostly on the blank of the magma, the gas content, the silica content, the amount of magma, or the temperature of magma. Well, they all have something to do with it, but mostly it does pertain to, if this would actually move, the silica content. Remember, that's that whole, is it like the chocolate milk, low silica, or does it act like a milkshake, a little bit thicker, more silica? The type of magma erupting from a volcano determines the volcano's size, age, shape, or location. The correct answer is its shape. And like I said, I hope you're pausing it, thinking about the answer, and then seeing if your answer is the right answer. Volcanic ash can be carried thousands of kilometers from an eruption by lava flows, pyroclastic flows, landslides, or winds. The key word here is thousands of kilometers. And that would be D, wind can carry it across the entire planet. Number 12, in a volcanic region, water moving through the ground gets blanked by magma or the hot rock. Water gets melted, water gets dissolved, water gets erupted, or water gets heated. I think there's really only one that stands out, that's heated. It says, describe how an old mountain belt located in the center of a continent would most likely form, like the Ural Mountains between Europe and Asia. Well, in the end, what happened was it probably formed when the continents pushed together along a collision boundary, kind of like the Himalayan mountains. But then they stopped pushing and the mountains wore down faster than they grew, and that's how you get an old mountain belt in the center of a continent. How are the locations of volcanoes related to tectonic plate boundaries? Think about that one. And volcanoes commonly occur at divergent boundaries and subduction boundaries, or um, those are the areas um, that have most volcanoes. And it does move a little bit there. What causes a shield volcano to be shaped like a broad dome? Think about what kind of magma does it have? And it's layers of low silica, so it just flows easily out. It just kind of oozes out on the top surface in thin layers, so it won't build up really tall. It'll just stay real thin and the layers and low. Sorry. And the last one, by what process can a volcanic eruption affect temperatures around the world? Well, that one, if you think about it, volcanoes erupt, they put sulfur dioxide in the air, makes this haze, which keeps the ash in the air for a long time. That haze decreases the amount of sunlight reaching the Earth's surface, which will eventually cause the temperatures to drop across the planet. So I think that's it. Yeah, that's it. So hopefully you did pretty well on that review. And make sure you get all those other things accomplished before you take the test, and good luck on your test.